SP3 hybridization of CH4 molecule. SP3 hybridization of CH4 molecule. We already know that carbon atom. Okay, valence shell having how many number of electrons is there? 4 electrons is there. This is the 1s electron is the core electrons. 1s is the core electrons. Core electrons does not participate in the bond formation. Only 2s and 2p. These only valence electrons. Valence electrons only can participate in the bond formation. So here valence electrons means 2s2 and 2p2. Here how many unpaired electrons is there? Only 2. 2 unpaired electrons is there. But in the case of carbon atom form 4 types of bonds. 4 types of bonds. How it is possible means the electron jumps from 2s level to 2p level. The electron jumps from 2s level to 2p level. So that's why in this case, how many number of unpaired electrons is there? Okay, 4 unpaired electrons is there. 4 unpaired electrons means 4 types of bonds is present. In the ground state, how many unpaired electrons is there? Only 2 unpaired electrons is there. So that's why carbon cannot form these 2 electrons. So that's in that cases the electron jumps from 2s level to 2p level. So how many unpaired electrons is there? 4. So that's why carbon can form tetravalency. And hybridization of carbon, sp3 hybridization. Here 2s2 and 2p2. This is the valence electrons. These are all the valence electrons. Here 3d orbitals is also present. 3d orbitals is also present. Total how many valence electrons in the carbon atom means 4 valence electrons. So first one is the s orbital. S orbital how many electrons is there? 2s orbital 2 electrons is there. So 2 electrons are present in s orbital. And px orbital. Px orbital having only 1 electron. And next py orbital having 1 electron. Here the pz orbital there is no electrons present in the pz orbital. So that's why in this case there is no electrons. In how bond formed between the carbon and hydrogen means in that case the electron jumps from 2s level to 2p level. The electron jumps from 2s level to 2p level. In the case of 2s level, 2 electrons are present. So that's why these electron jumps from 2s level to 2p level. So in this case, the electron jumps from 2s level to 2p level. So we have 4 unpaired electrons, and these unpaired electrons, 1 s orbital, 3 p orbitals. 1 s orbital, 3 p orbitals are intermixing with each other to form 4 sp3 hybrid orbitals. These are all the 4 sp3 hybrid orbitals. This is these hybrid orbitals are unsymmetrical. Unsymmetrical means we already know that unsymmetrical. Okay, so these sp3 hybrid orbitals having 4 unsymmetrical sp3 hybrid orbitals. These are intermixing with each other. These sp3 hybrid orbitals are intermixing with each other. Intermixing with each other to form like this. These 4 sp3 hybrid orbitals are intermixing with each other to form like this. This is the XYZ axis, 3D diagram of CH4 molecule. 3D diagram of CH4 molecule. Three D diagram of CH4 molecule. This is the SP3 hybrid orbitals. SP3 hybrid orbitals. In this case, this is the two-dimensional structure. In board, we have to write like this. This solid lines explains below the plane. This solid explains below the plane, and this wedge lines explains out of the plane. This wedge line explains out of the plane, and this dashed line explains behind the plane. Behind the plane. In board, we have to write like this. Here, these sp3 hybrid orbitals of carbon atom is overlap with the s orbital of hydrogen atom. Is overlap with the s orbital of hydrogen atom. Is overlap with the s orbital of hydrogen atom. We already know that the difference between the overlapping and hybridization. Overlapping and intermixing. Intermixing is formed within the molecule. The intermixing is formed within the molecule and overlapping is formed to different atoms. Here sp3 hybrid orbital and this is the hydrogen atom of s orbital. This is the hydrogen atom of s orbital and four different s orbitals is overlap with the carbon atom to form sigma bond. This is the along the internuclear axis, the bond formed between the along the internuclear axis. So that's why four sigma bonds is present. And in that case, someone okay, some exams are asking which type of bond is present in CH4 molecule means sigma sp3. Here carbon is the sp3. Here carbon is the sp3, and yes, sigma sp3 s bond is formed between the CH4 molecule. Instead of X, we have to take in hydrogen atom also. Instead of X, we have to take hydrogen atom also. We already know that this is the structure of methane. Methane. This is the carbon sp3 hybridized orbital is overlap with okay s orbital of hydrogen atom, and this is the structure of methane. And methane structure means tetrahydron. And what is the bond angle between the two adjacent atoms means? What is the bond angle between two adjacent atoms means 109 degrees 28 seconds. Thank you, students.